Okay, so I want to use greens to evaluate this thing where C is the unit circle oriented in the usual, right? Okay, so my curve is the unit circle, sorry, and my vector field is x squared y comma cosine y cubed. Some of you did try to do this by parameterizing the curve, which is not explicitly a terrible idea if you don't remember Green's theorem, right? Like if I say use greens and you don't remember greens, you could try to do it a different way and maybe you'd get some points at least, right, for trying. So if you try to do this the other way, it turns into a disaster really quickly. Why?
There's a lot of cosines and sines.
Yeah, there's a lot of cosines and sines, right? Because parameterizing the unit circle, right, you're going to go, okay, that's cosine t comma sine t, right? And then when you do f of r of t, right, you're going to get
X equals
cosine squared sine t. Okay, fine, maybe that'll work out. Cosine of sine cubed. Nope, you're done. That's not going to happen. Just quit. Move on with your life. Right? Which is why greens is a good trick to have in your back pocket, because greens on this thing is easy. If you remember greens. So to run greens, I need to think up which one of these is P and which one's Q.
X plus y is p.
The first one's P, the second one's Q, right? And so you need to say, all right, greens. To run greens, I need what? What are the things I need to check about my curve? Needs to be closed. Check, it's a circle, right? Simple. Check, it's a circle. Piecewise smooth.
Believe so.
Still a circle. And it needs to be counterclockwise oriented, and they told me it was. Cool. So I'm allowed to run greens, so I'm going to. And greens says that this should be the integral over the disk now.
Of q partial of x.
Okay, so I need the partial of q, so that's cosine, partial of cosine y cubed with respect to x. Minus the partial with respect to y of
x squared y.
x squared y.
And
then I need d,
which ends up being r d r d theta, if that's what you were looking for.
yeah, and because it's a disk, you're probably going to want to do polar, right? Okay, but let's take care of derivatives first, and then we'll. So I'm going to get the integral over the disk of, what's the partial with respect to x of cosine y cubed?
0. Because there's no x.
Yeah, there's no x's, so that means it's constant with respect to x, so you get 0 out of that. Whoa! The nasty bit dropped out.
Entirely.
Right? Okay, cool. And the other bit you get?
Negative x squared.
Okay, so slap the negative up front and put your x squared there. So all I need to do in the end is integrate x squared over the disk, d area, and slap a negative sign on the outside. Okay, so then I'm going to, what? What's my next step here?
Turn d and dA into actual rdr and the disk.
Yeah, make this thing polar, right?
Yep.
Okay, so you'll get minus the double integral of something r dr d theta, right?
Well, we know it's x squared on the inside still.
Okay, it should be x squared on the inside, but...
Oh, right.
Oh, right. Yeah. X's aren't allowed in here, right?
Yeah.
That needs to be converted to polar. So that needs to be, what's x in polar?
R cosine theta.
R cosine theta.
Squared.
And we need to square that. And your r's, where do they range in the unit disk?
0 to 1. It's a disk.
They go from 0 to 1. And the thetas go
0 to 2 pi because it's a full circle.
0 to 2 pi because it's all the way around in the disk. So you should get minus the integral from 0 to 2 pi of cosine squared theta d theta times the integral from 0 to 1 of
R cubed.
r cubed dr. You guys see I pulled that, what did we call that trick? I don't know.
I can't remember the name of it.
The double integral trick or whatever.
Yeah.
Where I had a product of two functions, right? One that only depended on r and one that only depended on theta. And so I took them apart. Okay, so I got to here. So what's the integral of r cubed dr from 0 to 1?
1/4.
1/4. So I got minus 1 over 4. And I need the integral from 0 to 2 pi of, how do you integrate cosine squared?
You could translate cosine squared theta to 1 plus cosine of 2 theta over 2.
Perfect. So you need the half angle identity, right?
A lot of people are like, yeah, this is where I fit.
And then, what's the integral over 2 periods of cosine? 0.
So you get 1/2.
Well, times 2.
So I got minus 1 over 4 times 1 over 2 times 2 pi, which is negative pi over 4. And the fact that it was simple is how you know you did the right thing. Cool? Questions, deals? Okay, cool. Yeah, mostly the trouble is that it seems like greens wasn't exactly in everyone's head. It was like almost in everyone's head. And almost and greens don't go together very well.
Yeah.
Greens is really specific. And if you have the order of differentiation or something a little bit wonky,
Yeah.
or you don't quite know how to pick out P and Q, everything can go really, really wrong really, really fast.
Yep. There's a simple mistake of Q and P just gives you, if you find the derivative of y of cosine of y cubed.
Yeah, so this question is actually almost tragic to grade because a lot of you guys did like almost the right thing, but you screwed up greens at the beginning and then everything turned into horrible gibberish. It's like, I feel bad because most of the stuff you did afterwards was right, you just screwed up the beginning, so I tried to draw some kind of reasonable like weighting on that. But if you ever have to actually use greens, look it up.
Yeah.